Today we're going to look at the idea of logarithms and logarithmic functions. Now, before we go into the examples, let me just explain a little bit about this function which is new to you. So in indices, we learned that we can raise numbers to a certain powers. But what if we just wanted to look at the powers instead, okay, and not just with the base? Logarithm is a way, or rather a function, okay. So if we have a log base a, okay, this function takes a number and returns the power when the number is rewritten as a power of a. Okay, so just take for example, if x is equals to, let's say in this case, 9. What is log base 3 of 9? Okay, log base 3 of 9. In other words, if I were to write 9 as a power of 3, what would this power be? Okay, that would be the output of this function. Okay. So we know that 9 is actually 3 squared, and hence, okay, so 9 is 3 squared. Let me just write 3 squared here. Okay, so log base 3 of 3 squared gives you 2, right? Because it returns the power, which is 2. Let's look at some other examples to clarify this. Okay, let's change the base to, let's say, 10, and let x to be 10,000. Alright, now if I were to write log base 10 of 10,000, what do you think would be the answer? Now note that 10,000 is actually 10, okay, the base of the logarithm, raised to the power of 4, right? So the output of this is actually 4. Things become a little bit difficult if, let's say, x is cannot be re-expressed as a power of the base easily. For example, let x to be 25, and hence log base 10 of 25 will not be a whole number. Of course, you can use your calculator to compute base 10. Okay. Another one, for example, would be, let's say, log base 2, and my number x is actually 1 over 32. Okay, log base 2 of 1 over 32. Okay, it's a fraction. Okay, so what would be the answer? Now, if you take a moment to think about it, 32 is actually 2 to the power of -5, right? Okay, so since -5 is the power, when I rewrite it in terms of base 2, the answer to this is -5. So as you can see, logarithms can take -5, it means negative numbers, or positive numbers. However, okay, the number you put in, x, must be positive. Let's extend this idea further, because if you want to manipulate logarithms, we need to know 3 basic laws. Okay, the first law, we call it the addition law. Okay, when m and n are taken as a product, and you take log base a, we could write it as a sum of 2 logarithms. Okay, so let's take for example log base, let's say log base 3 of 3 squared times 3 power of 4. Okay, we see that this is the same as log base 3 to the power of 6, right? Because we add the powers together, so we end up with 6. But it's also the same as considering log base 3 of 3 squared plus log base 3 of 3 to the power of 4, right? Because each of them, this will give you 2, and this will give you 4. So 2 plus 4 also gives you 6. For the second law, okay, this is the law of difference. if I take m divided by n, I end up with the difference of log base am minus log base a of n. So take for example log base 3 squared over 3 to the power of 5. So we get log base 3, 2 minus 5, negative 3. So we end up with negative 3. Okay. This is the same as log base 3 squared minus log base 3 to the power of 5. Okay. Because this also gives you 2 and this gives you 5. So 2 minus 5 is negative 3. Last but not least, log base a, if I have m raised to the nth power, is the same as n log base am. Okay, this is as if the power was so-called brought down. Okay, you can think of it this way. Okay, now this wouldn't surprise you. So for example, if I have log base 3 to the power of 4, it is 4, right? And it's the same as 4 log base 3 to the power of 1. Okay, log base 3 of 3 to the power of 1 is equals to 1, right? So I still end up with 4. So as you can see from here, okay, the left hand side is equals to the right hand side, and it is as if, okay, I brought the 4 down. Okay, these are the 3 basic laws that you need to know to solve logarithmic equations. Okay, let's first look at an example of how to evaluate and simplify log functions. Okay, evaluate 2 log base 2 2/3 plus log base 2 81 over 8 minus 2 log base 2 3 over 4. So in order to simplify this expression, okay, first we must try to rewrite it. Okay, rewrite it carefully first. Okay, so at least we now have base 2 for each term. So for the first term, okay, let's just copy this. Okay, for the first term, it's going to be equals to, okay, by the third law, log base 2 over 3 squared. Right? The second term, let's leave it alone. The third term, again, we can bring up the power 2. So we can first think of these two as a sum, right? And from the first law, we can rewrite it as log of a product. Okay. After we do that, we will try to take the difference. In other words, we apply the second one, law of difference. Okay. So for this case, I will get log base 2 4 over 9 times 81 over 2, okay, minus log base 2 3 over 4 squared. And of course I can do the difference as well. So 4 over 9 times 81 over 2 divided by 16 over 9. And upon simplifying, I should get 8. Okay. But then again, 8 is 2 cubed, right? So I get 3. Let's look at the last example. How do we solve logarithmic equations? Okay, let's see. Solve log base 10, 3x plus 2 minus 2 log base 10x equals to 1 minus log base 10, 5x minus 3. So again, all the bases are the same, and hence we can apply the 3 laws of logarithms easily. So again, we try to rewrite them as log base 10 without anything in front. So I bring this 2 up, I get minus log base 10 x squared. Let's bring the other term over, plus log base 10 5x minus 3, and leave the 1 alone. So for the first two terms, I can apply my law of differences to get log base 10, 3x plus 2 over x squared. Then I apply my sum to product to get log base 10, 3x plus 2 times 5x minus 3 over x squared equals to 1. So log base 10 of this big expression is equals to 1, right? 1 is the power when the base is 10. So this implies that I have 3x plus 2, 5x minus 3 over x squared equals to 1. Equals to 10, sorry, 10 to the power 1. Okay, think of it as, for example, if I have log base 10, x is 1. X must be equals to 10 to the power 1, right? Because 1 is the power when rewritten as power of 10. So all that remains is to simplify this further into a quadratic equation since there's no more log function. So I get, okay, let's expand the top. So I get 15x squared minus 9x plus 10x minus 6. Multiply both sides by x squared, I get 10x squared. So I get 5x squared plus x minus 6 is equals to 0. So all you have to do now is to try and solve this. So I get 5x plus 6, x minus 1 equals to 0. So x equals to negative 6 over 5 or 1. Whenever we do log equations, we must always check back the answer. In this case, we have two answers, two solutions, one positive and one negative. If you look back, okay, just by looking at the second expression here, this is 5x minus 3. If x is negative 6 over 5, 5x minus 3 will be negative, right? And I cannot take negative log. So this is rejected. Hence the answer is x equals to 1. And that's the final conclusion.